The paper is Serializable Snapshot Isolation in Postgres. It's a 2012 paper. The paper describes the implementation of Postgres' new serializable isolation level, which is based on serializable snapshot isolation technique. It was the first implementation of SSI in a production database, as well as the first in a database that did not previously have a log-based serializable isolation level. Authors talk about their experience of implementation of a new log manager, a technique for ensuring memory usage is bounded, and integration with other Postgres features. They also introduce an extension to SSI that improves performance for read-only transactions. Postgres serializable isolation level is evaluated using several benchmarks, and it's shown that it achieves performance only slightly below that of snapshot isolation and significantly outperforms the traditional two-phase locking approach on read-intensive workloads. Authors evaluated the performance of Postgres on 3 workloads: the SciBench micro benchmark, a modified TPCC like transaction processing benchmark, and the Ruby's web application benchmark. They used several hardware configurations to test both the CPU and disk bottlenecks. Now let's look at the contributions of the paper. Serializable transactions can simplify development by allowing database users to ignore concurrency issues, an advantage that becomes particularly relevant with today's highly concurrent systems. Despite this, many users are unwilling to pay any performance cost for serializability. For this reason, Postgres historically did not even provide serializability, instead offering snapshot isolation as its highest isolation level. Authors addressed this in Postgres 9.1 with a new SSI-based serializable isolation level. Experiments show that this serializable mode provides performance similar to snapshot isolation and considerably outperforms strict two-phase locking on read-intensive workloads, hopefully making it a practical option for developers who would have previously opted to use snapshot isolation and endure the resulting anomalies. Now let's give this paper a PS score. Overall, it's interesting read with some dense parts, so it gets 8 out of 10 on readability. It's 12 pages long, which seems appropriate for the material presented, so on length it gets 9 out of 10. Reproducibility might be a challenge, but users can always refer to Postgres implementation, so it gets 8 out of 10. Industry value is pretty high, as this was the first implementation of SSI in production DB, so it gets 10 out of 10. I learned quite a bit about enabling SSI, its need and trade-offs involved, so on Learning Meter it gets 9 out of 10. So the overall PS score is 9 out of 10.